So we have, what would be the answer to this first question? So what is the exponent that I can put on a base 2 to get to 8? Now, I don't want to write it out this way, but what this is essentially saying is 2 to the what power equals 8. That's what this is saying. So, not 4, 3. It's okay. And then I'm going to go to the next parentheses, and what this one is saying is 3 to what power is equal to 9? 2. Bring down the subtraction sign. This next one is saying 5 to what power equals 1 over 25? -2, because this one's a fraction, so bring down the -2. And then we have our last one. 4 to the what power is 4? 1. So after you do that, we just do our order of operations. So what I have here is 3 times, and then this becomes a plus, so that would be 2 plus 2 plus 1, which is 3 times 5. So who got 15 for their answer? And that would be your final answer. So the main thing to keep in mind as I'm trying to think ahead to our test is when you subtract a negative, a lot of times they will drop one of the negatives and keep it a subtraction. But remember, a double negative becomes positive. All right, this last one, this is not a full statement. Okay, so I cannot figure this out because what this is saying is we don't know the answer. So what I'm going to do is a rewrite. So when I do my rewrite, it would be 5. Remember, this is my exponent to the power of 3 equals 8x plus 45. Go ahead and solve it out. Figure out what 5 to the power of 3 is, and then solve it. So 5 to the power of 3 is what? 15? What is it? 125. 8x plus 45. So then we would just subtract the 45. So what is 125 minus 45? 80. And then we would divide by 8. So my final answer would be what? 10. All right, any questions about the Bell work? Because that's not a full summary of what we did Monday, but it's, pretty much. We did some other stuff, but questions or comments? I'm going to try to show you your quiz at the end of class. So, all right, so now we're going to finish out 5.4. So again, just a reminder, 5.4, that homework is due on Friday. You do need graph paper for 2 questions. So I have graph paper. If you don't graph it on graph paper, I'm not giving you full credit. If you don't have graph paper, there is a tray of graph paper underneath the screen. You only need 1 sheet. You could probably even just do half a sheet, but I don't feel like cutting them in half. That's all you need. Any questions about homework 19? All right, so now we're going to talk about graphing. So I think did I give you this whole slide? Yeah, I think I did. This is the whole slide. Go ahead and glue it down. So if you're titling it, we're going to title this. This is the end of 5.4. Well, really it's the beginning, but I flipped it. But we're going to graph a log function now. So go ahead and title it Graphing Log Functions. And then glue down that cutout. I just pretty much gave you the whole slide so we don't have to waste time. And if you come across a glue stick that is dried out, just throw it away, please. I have more, or I can get more. Okay, so a log, remember we talked about on Monday, everything in math has an opposite. We talked about the opposite of adding is subtracting. The opposite of multiplying is dividing. The opposite of a square root is the exponent of 2. The opposite, or the inverse, more specifically, of an exponential is called a log. Okay? So, how do we do it? Now this first step is kind of optional. As you learn and you become more familiar, you'll probably just skip the first step and go to step 2. But we're going to create an exponential table, an exponential parent table using the base of the log. And then we're going to flip x and y. Because after we flip x and y, it switches from an exponential to a logarithm. We always apply the transformations the same. It will always be x plus h, y times a plus k. So let's look more specifically as where are we going to find these pieces of information? A is always in front of the log. So that's where you're going to find A. H will be inside of the parentheses, and you will always flip the sign for H. So if you don't have a parentheses, that means that H is 0. And then K is in the back. So everything is opposite from an exponential. Remember, an exponential, the domain was always all real numbers. Well, now, because we're talking about a log, it's your range. This will always be the range for every single log function. Every single log function has a range of all real numbers. Okay? Now, your domain will depend on h. The domain will be h to infinity. Exponentials have a horizontal asymptote, but because this is the inverse, we have a vertical asymptote. And the vertical asymptote will occur at h. All right, so let's just go ahead and practice graphing just a general log function. I forgot to pass out graph paper. Let me see, how many graphs do we have today? We have 4. So I do have some little graphing squares. Let me go ahead and pass these out. Who needs the graphing squares? Okay. Pass these out. Okay, let me just come around. All right, so you need this 2. You don't have to keep your hands up for this stuff coming around. I got you. Just about everybody pretty much. You need something? Did I miss anybody? So I'll give you a second to, you know, I cut these out pretty fast, so I'll be just chopping them with the guillotine. So go ahead and get your paper all set up. We're going to graph the function y equals log base 2 of x. leave them on the table in the front. So the first thing we're gonna do, I'll give you all a couple more minutes because I see people still gluing. Now, if you don't see a base on the log, what does that mean? What's the base? 10, right? So if it's a base 10, we don't put it there. It's kind of like 1x. We don't put a 1 in front of the x. Or x to the power of 1, we don't put a 1. If the base is 10, we don't put it because that's a common log. All right, so the first thing we're going to do, and this is just the parent, is I'm going to create an exponential table using the base. So you see how this is a base 2? So I'm going to make a table for y equals 2 to the power of x. I'm not going to graph this table. Now, as you become more comfortable, you'll probably skip this first step. So, and I still have it on the board from the last quiz. So 2 to the power of -1 is 0.5. Anything to the power of 0 would be 1. 2 to the first is 2. 2 squared is 4. 2 to the power of 3 is 8. Okay. Now, to find the inverse, does anybody remember? How do you find the inverse of a table? Flip your x and y. Look at y'all. So that's what we're going to do. So what I'm going to do is I'm going to take all of my x values. I'm going to put them here for y. So I'm going to write my -1, my 0, my 1, my 2, and my 3. That's now my y values. And then I'm going to take my y values for my exponential function and list them under x. Now this is your parent log table for a log base 2. So a log function, when I kind of think of what the graph of it looks like, the only thing I could think of would be a lowercase r. This is going to look like a lowercase r. So this is our parent. So because h is 0, we're going to draw in a vertical asymptote now at x equals 0, which is my y-axis. So I'm going to draw it in. So you have a highlighter or color pencil, drawing your asymptote. So this is a vertical one, not a horizontal. So this graph is not going to cross through this wall. All right, and then after you draw that in, go ahead and plot your points. So I have a point at 1, 0. I have a point at 2, up 1. And I'm going to go to 4, up 2. And then 8, up 3. I don't even know why I put the first point in there. I think it's just like, I feel like I need to. But I never graph it though. It's just weird. So we have to remember, so this is going to come in, it's going to hit these 4 points, but it can't go through the wall, so it's just going to go straight down. So again, the only thing I can think of that looks like is a lowercase r. That is what a log function will look like. On the test, so on the quiz, you have to graph an exponential, but on the test, you're going to graph a log. So the main thing to keep in mind is we do have to flip it. We have to flip our x and our y. Now, because of that wall, my domain is not all real numbers anymore. My domain is 0 to infinity. No brackets. No brackets. Because X will never be 0. It's just going to be really close. It'll be 0.00000000001, but it'll never be exactly 0. So we're going to put a parentheses on the 0. But now my range is all real numbers, and that is for my parent function. So the main thing we need to keep in mind is when we graph our log functions, we have to flip the table. Now, some people will just go straight here, and they'll skip the first step. They'll just, just make their exponential table backwards. But I don't want anybody to get confused. We only got 2 more tests, right? We almost done. I want everybody to win. So you don't get a cookie for flipping or skipping the first step. If you gotta do the first step, do the first step. Any questions about our first graph? All right, let's get ready for graph 2. Go ahead, get your paper set up. Now we're gonna add some transformations. I'm assuming you're gonna come back. You probably just gotta pick up something. Okay, so we've already did the first 2 steps on the last one, but I'm just gonna do it anyway. So again, my base is 2. So I'm gonna start off by making this table. And you should be pretty fast at making this first table because I feel like we make this a lot. That's my first table. I'm not going to graph that. I'm not graphing it. So now we're going to take that table and flip it. I'm not going to graph that one either. So my A value is the number in front of log. So we don't see anything, so that means that A is 1. H is always inside and the opposite. So what is H? Positive 2. K is positive 1. So I'm going to take this table, my second table, I'm going to add the H, which is 2. Go ahead and add 2 all the way down. And on the Y side, I'm multiplying by A and adding K. Well, since A is 1, I'm not going to multiply by 1, but I am going to add the 1. So now make your third table, and then this is the table we will graph. So you're going to add 2 to your X values, add 1 to your Y values. Now, personally, before I graph, I like to draw in my vertical asymptote. Where am I drawing the wall at now? At positive 2. So pick up your little highlighters. And we're going to draw in our wall at positive 2. This is my wall. I can't go through that wall. And then go ahead and plot your points. Struggling over there, huh? It happens. That's what your graph should look like. So I drew my vertical asymptote in at x equals 2. I'm going to go ahead and write that down. My domain will be what? 2 to infinities. No brackets. Some people still put brackets on the exponential on the quiz. Don't put any bracket. Exponential, logs, we don't have a bracket. And our range will be all real numbers. All right, any questions about the graphing? So we got to make a few more tables, right? We got to make an extra table. But that's what we got to do. So I'll give you all a second, and then I'm going to put up our next one. We only got a couple more. And then we will be finished with our graphing. So go ahead and get your paper set up. I'm changing it now to a base 3. So go ahead and set up your paper. So what's your first table? What would your exponential table be that we're going to start off with? Y equals what? What's the base of our log now? 3. So we can't put as many points down because 3 is a bigger number. So we won't have that many points. So we're going to make our table y equals 3 to the power of x. And we will only be able to do -1, 0, 1, and 2. That's all we can do. We can't go to 3. So go ahead and figure out what those 4 values are. We're not graphing it. Do not graph it. Now, are you all faster at making these exponential tables? Hopefully. Because what is 3 to the power of -1 as a fraction? 1/3. And I'm going to write it as, again, why do I put this point and I don't know. I don't have an answer for that. I just feel like it has to be there. Do you have to put it? No. You can absolutely start your table at 0. I don't know why. I just feel like I have to do that. Anything to the power of 0 is 1. 3 to the first is 3. And 3 squared is 9. All right, so now let's take that table and we're going to flip it. We're not graphing this table either, though. So my A value is still 1. Where would my H value be? Where am I going to draw in my vertical wall? -4. K is at -3. So you're going to take all of your X values, you're adding -4. It's always H plus X. It doesn't matter what kind of function it is. An exponential, a log, a square root, a sine, cosine, tangent, when we start graphing that next semester, it's always H plus X, and then the Y is multiplied by A and adding K. But again, since A is 1, I'm not going to include that, but I am going to add the -3. So make your third and final table, and that's the one you're going to graph. I'm going to start off by putting in my vertical asymptote at X equals -4. And again, you really just need 3 points. You don't have to do the first one, but it's just, it's a psychological thing. I've been doing it for 18 years. I just can't stop. I just do it. It just has to be there. Do I have who? Yeah, one more. And try not to, like this graph, it doesn't go up like that. It's going to increase at a very slow rate. So that is what my graph looks like. So we have our vertical asymptote. What would our domain be? Okay. And then of course our range this time is all real numbers. All right, we got one last one and then we will be finished. Any questions so far? What y'all think? We did graph this in Algebra 2. I don't know if y'all remember it, but graphing logs is a part of Algebra 2. All right, anybody need more time with example 3? All right, last one. We're gonna go back to a base 2. And this time we're gonna add an A value to see what that looks like. I'm just setting up my little log base 2 table. And then, you all have this log base 2 table, so this is our third time using it, so you may not need to. So. So for this one, A is 2. What is H? -3. And what's K? -4. So this time we do need to consider A, because this one is vertically stretched. So I'm going to add the -3 all the way down. And then these values, I'm multiplying by 2 and adding -4 all the way down, which is the same as subtracting 4. So go ahead, take a few moments. And this one is going to look like it's still should look like an R. I can't think of anything else to. Oh, I put my vertical asymptote in the wrong place. Let me fix that. I was like, this don't look right. It's too far away. Right, draw that in. 3, -3 is right here. All right, and when I call your name, you can see your quiz. And if you wanted to, the quiz average was really high. I think this class had a 90% average, so. All right, so this is that last example. Now you can finish all of homework. I can't remember the number, the one that's due Friday.